Let's look at this question. Determine the distance h. Look at this h. It's here, this h. And this shape that looked like a U. Look at this. This is solid. And that's an open space. Okay? It's a U. This is B. This is A. And this is the line B, B prime, or B dash. And this is small h, and this is KP. Let's look at the question. Determine the distance h. So you want to find this h. Okay? Determine the distance h so that the centroid of the shaded area. So the centroid, this is the shaded area. This solid line is the shaded area. This is open space. This white is open space. So the centroid of this shaded area is as close to the line BB prime or BB dash as possible when. So the centroid is very close to line BB dash as possible when K is 0.2. Let's leave K to 0.6 later on. So K is 0.2. So this K is 0.2. Let's look at the answers for this question. So we have to draw the things again. And we should find out, first of all, we should format a table like this. We'll put component, the outer rectangular, and the inner rectangular. Let's go for the outer rectangular, the big rectangular. Okay? So the outer rectangular is this huge shaded area. Okay? And because for this type of questions, I'll take the whole rectangular. Okay? And I'll subtract the open space from it. So initially, I'm going to take the whole rectangular. See this rectangular? What's the area? A times B. That's the area of a rectangular. A times B. So the area of the rectangular the area of this outer rectangular is A times B. Now, since we are dealing with the distance h, which means we should be dealing with the y. We're not going to take x bar. We don't care about x bar. X bar is in the x-axis, in this direction. We are caring only about the y-axis. So, if the whole thing is the rectangular, from the BB prime or BB dash, what is the centroid? This is the rectangular. The centroid is A over 2 from BB prime. That's simple. Rectangular, the centroid is half the distance in the y-axis. So the y prime is A over 2. Now, the third column, you multiply y prime times A. So AB times A over 2, it's A squared times B over 2. Nice? Now, let's look for the other area, which is the inner rectangular, the open rectangular. And that's why I will start with a minus, because I'm going to subtract it from the total rectangular, from the outer rectangular. Okay? So, I'm going to start with a minus. Look at this. It's KB times this distance. What's this distance? If you just zoom out, a little bit zoom out, it is A minus H. This one, A minus H. Okay, so it's A minus H times KB. That is the area. And this is, where is that? This is where? That is in the open space. White stuff. This one. That's the minus. So, minus KB times A minus H. That is the area. Now, where is Y bar? Y bar, it is the centroid of this away from the x-axis, away from B prime. We just put this one as the x-axis or as the axis. Okay, so this is what? This is A minus H divided by 2, because this is the small rectangular, right? The inner rectangular. So this one is A minus H divided by 2, because we will have the half of the rectangular, plus H. So A minus H divided by 2 plus H. So we're going to do it like this. Look, A minus H, A minus H over 2 plus H. Now we should multiply this whole thing times this. Okay? So minus KB, A minus H times the whole thing. So if you multiply this times this, you will end up with this. Of course, this is going to be what? 2H over 2. And then you multiply it with the whole thing. So minus KB, A minus H times H plus minus KB, A minus H squared over 2. And if you do the whole thing, you will end up with something like this. If you multiply this, it's going to be minus KB, A minus H times A plus H over 2. Now, you sum up all the areas, this plus this, you'll end up with this. AB minus KB, A minus H in parentheses. You sum up the Y bar times A altogether, you'll end up with something like this. A squared B minus over 2, this one, over the whole thing here. Minus KB over 2A minus A squared minus H squared. You can see that A minus H times A plus H, it's A squared minus H squared. So now we have two equations. Remember that the first part, he assumed that K is 0.2. Look at this. Look at this. K is 0.2. So now we're going to put K is equal to 0.2. So we're going to, when K is 0.2, we're going to put K here. We're going to make it 0.2, and we're going to make all over for the other one K 0.2. So you'll end up with an equation like this. AB minus 0.2 B times A minus H. You'll end up with an equation like this. 0.8 AB plus 0.2 BH. We'll do the same thing for the second equation. Just put 0.2 here. You'll end up with, if you rearrange the whole equation, you will end up with an equation like this, rearranging, and you will end up with 0.4 A squared B plus 0.1 BH squared. Okay. Now, if you want to find the centroid of the whole shape, the whole rectangular, minus the open space, the small rectangular inside, you have to divide this over this. So Y bar is equal this summation of Y bar A over summation of the area. Just put the things in top of each other. And that is the answer for Y bar. But that's not what he wants. He wants what is the minimum distance from the B prime for the centroid. Now for this, you have to find the derivative, dy over dh. So you're going to derive this one. You're going to find the derivative of d over dh for this Y bar. And it will be equal to 0 if you want to find the minimum y. Okay. And if you want to find the derivative of this, you could do it like this. Take the bottom, brought it up, 0.8a plus 0.2h times what is the derivative of the inside of the top one. This is 0 since this is like a constant. Here it's going to be 0.2, 2 times 0.1 h. And then minus, you put now the top here, and you do the derivative of the bottom one. Of course, If you put the bottom the derivative the bottom, which is this is 0, 0.2 only, the whole thing is equal to 0. For this, you'll find the answer like that, and you rearrange, you'll end up with an equation like this: h squared plus 8ah minus 4a squared equal to 0. And this is this is very simple. H squared is, you could assume it as x squared plus 8ax minus 4a squared. A is constant. So if you do this way of doing the quadratic equation, you could find h as a function of a. So h is equal to 0.472a. Remember this from calculus? This is the quadratic equation. So we found h, okay? And we take only the positive root. You could apply the same thing for k.6. You'll end up with, if you could do summation of area, summation of y squared a, y bar a, finding the y bar, and then doing the same derivative, you will get the same thing. H is equal to 0.387. Thank you.